Transistors are going to be doubled every 2 years. This is called Moore's law. Moore was a former CEO of Intel, and he has told that law, and it is still being followed. Now my question is that to the electronics and semiconductor fellows and veterans, that is it still true in today? Different people has told different opinion about this. So we'll talk about this in today's discussion. We'll talk about that more and more transistors are going to be integrated in a single integrated circuit, how long it is viable. We'll talk about silicon photonics, that is a new era of electronics. If Moore law is dead, then we need to move further away with some other technologies to be incorporated in the chip technology. And last but not the least, we'll also discuss about in general what is the applications of these Moore's law, chip designs, and the silicon photonics, and what are the research are being done. So be with me till the end of the video to know all about this, and there will be a lot of fun to know the newer things itself. The technology was 128 nanometer, and then it became 65 nanometer. Then it still advanced to 28 nanometer. I have seen 28 nanometer technology during the early days, and now there is 4 nanometer, 3 nanometer. How far it can go? Regarding 2 nanometer, I can give an idea that TSMC company from Taiwan, they are in production. Probably that will come out in 2025, 2026. But before that, they have started innovating 1 nanometer technology. But is it viable beyond 1 nanometer? What we will do? So then we question about the Moore's law. Regarding Moore's law, I think in the year of 2022, NVIDIA CEO told that Moore's law is dead. We need to move further ahead with other technologies. But still then, Intel is shouting about the Moore's law is still viable in today's technology. So there is a question is that even if you congest more and more transistor in a single integrated circuit, so there will be some side effects, and you need to deal with these side effects. The first side effect is going to be the heat generation. There will be a lot of heat generation as we keep more and more transistor in a single circuit. There will be some other side effects like some functionality may not work for the chip. There will be some other problem regarding that viability of the chip. So we'll talk about that, and we'll also talk about that what is silicon photonics. That is a new term. This is not a new term. It has been researched for a long time, and still it is being researched to do further improvement on it. And we'll go with the silicon photonics in the future of the tech. What is silicon photonics? Silicon photonics is something where electrical signals are used to drive the integrated circuit. Now we talk about that optical signal will drive the integrated circuit itself. So means in the single chip there will be an optical portion, there will be a electrical portion that will work in the single chip. This chip is called PIC, or Photonic Integrated Circuit. As we all know that the speed of light is almost highest compared to any kind of electronic signal or anything. So that's why this technology has been used in the single integrated circuit, and that's called the silicon photonics. Now regarding the silicon photonics is extensively researched nowadays. Now companies like IBM and Intel, they are doing research on the silicon photonics and trying to use this in data centers where the speed is utmost necessity, and they are also trying to employ it in cloud computing, in AI, and also in telecommunications. Regarding the interconnects, the electronic interconnects are now being replaced with the optical interconnects. So that is a application of silicon photonics, and it is being researched a lot nowadays. Listen till now, I would request you to subscribe this channel, where you will get a lot of discussion over this kind of technology. Now I am going to tell you a story. Is integrating more and more transistor and making the chip size small is enough to improve the overall technology itself? No, the answer is no. There are some other ways to do it, that is called chip packaging. Now there are a lot of things happening in chip packaging, in the chip manufacturing side of the things. There are a lot of improvements. So if we cannot improve the chip horizontally, that means if the chip size is much longer or much is not narrower, if you improve the technology, then you can do it vertically. That's why called 3D IC has been incorporated, and this is the technology. I think TSMC is basically really following this. And then there is Intel. Intel has something like FinFET technology. Intel has gate-all-around technology, where there are a lot of things happening with surrounding the technology towards throughout the periphery of the chip, and also cutting down the chip in the corner of the chip, so that the placement of the chip can be improved. So there are a lot of things, lot of stories is happening. There are companies like Intel, there are companies like TSMC, and then Broadcom, and then Qualcomm, and these companies are really working for the newest technology, especially for the artificial intelligence, because artificial intelligence require lot of complexity and these kind of operations. Not the least, I want to share information regarding. Recently, I have launched a new book called Semiconductor for All. It has 25 fascinating topics on semiconductor and artificial intelligence. If you are interested on these, modern technology on semiconductor, I would request you to, buy this or purchase this book from Amazon. I will give the link of this book in the description section, so you can get help on that. And also I would like to request you, if you have any kind of queries regarding the silicon photonics, Moore's law, or anything in today's discussion, please drop it in the comment section, and I will reply on this comment itself. And if you have some interesting topic that you want me to discuss on this channel, so please also put this in the comment section, and that will be highly appreciated. I will appreciate this very much. So with that, I'm going to do a sign up, but before that, please subscribe this channel, and if you like the video, please do a like and share of this video itself. With that, Subhasish Chakraborti signing off.